My name is Soumil Sarvaya. Today I will be giving an overview of the project which we have implemented towards our course, that is Intro to Big Data. I will be giving this presentation with Karan, Rishabh, Suchit, Anmol and G. The name of our project is Munching Num-Num, which is based on Yelp Dataset. The goal of our project was to explore the domain of big data. We have cleaned and processed the data, used data mining techniques to discover knowledge, and we have visualized the discovered knowledge in R. We have broken down the project into various tasks. The first task is data cleaning task, second data pre-processing task, third mining task. We have modeled the data and compared the different models. We have also visualized the data. Now Suchit will be giving a brief description about cleaning tasks.
Hello guys. So for data cleaning task, first of all, in our Yelp dataset, we had 4 tables. So initially we found missing values in some of the rows. So what we first did was that we thought that we would remove all the rows which had null values in them. Later we came to a conclusion that rather than doing that, we could actually use weighted probability and fill in those null values with them. And we also had some outliers in the review star column where actually our review stars is only from 1 to 5, but some values were actually abnormal and more than 5. So we had to even check out for them, and we just we used some techniques by which we gave them the most appropriate values of the review stars. And there were also some duplicate data, like there were some rows which were repeating again and again in the dataset and they were exactly the same. So we just removed all the duplicate data. Now, Anmol Guessing is going to give us more information about data pre-processing tasks.
Now we come to the data pre-processing part. In the data pre-processing is converting your data from a raw form to a form that is understandable. In data pre-processing, we consider 2 parts. One is sampling and the second is feature extraction. Sampling is basically taking a part of the data and using it to make a meaningful data set. Yelp has more than 14 million reviews. So it doesn't make sense to understand the entire data set as a whole. What we do here is basically we sample the 14 million. We choose from these 14 million records and sample only 60,000 records of those, and make that 60,000 records a meaningful data set, so that this data set can be used for further analysis. Also, from this feature extraction, we predict the positive and negative reviews. Now, how do we do that? To do this, we convert the review text into a feature vector using the TF-IFT vectorization format. The TF-IFT stands for Term Frequency Inverse Document Frequency, which takes in each frequency of each word that is present in the entire 60,000 data samples and gives us the frequency, how good or how bad, or the actual frequency, what it stands for. Now coming to the data mining task, I will bring a call upon Jeet.
Thank you, Anmol. As we've understood the various pre-processing and data cleaning tasks in the previous section, let us move ahead and understand the various data mining tasks that we've performed on this repository. As we all know, Yelp repository comprises of businesses and chains which revolve around the food industry. We've obviously used various factors which pertain to the stars and the reviews that have been generated by Yelpers around the globe. So moving on, we've performed tasks like classification, regression, and decision trees in order. So first, let us understand about classification. We've used k-nearest neighbor classification algorithm to classify our various test labels in classifiers like business stars, review stars, and usefulness of a particular review. To begin with, the business stars is a collection of attributes that a business organizes in and around itself with. That is, the ambience, the food, the service, and the various facilities that one provides to its users when they come in to fine dine or just grab a snack and move ahead, as in Wi-Fi, parking space, whatnot, etc. for which we've used three categories as attributes to our data learning, which is review counts, the check-in count, and the city that it's situated in. If you see, the best attribute that describes this classifier is the check-in count in correlation with its review count, because it's important to understand if a person who has reviewed this place has been to it in the first place or no. Sometimes it happens that people do write a review without entering or venturing into that place because they just want that place to gather a higher rating for people to go in and dine. And thus we understand that the accuracy that we get is in and around 60 to 65, which means that there is not much sparsely distributed data to clearly classify whether this review or the business is as good as how it should be based on various factors that a pattern prevails for certain businesses which generate a 5-star on a regular basis. Moving on, we have review stars, which, as the name suggests, is clearly based on the food or the service that particular industry provides. As in our case, the Yelp database is the food quality. So for this, what we've understood is that we've categorized the ambience and the food quality together, which means the review funny, review cool, and the review useful attributes are used towards guaranteeing whether this review star is worth a 1 or a 5 on its scale in range. Again, we get accuracy of 65%, where the review useful category is one thing which is being capped to a number 100 even if it goes beyond this. This is nothing but the number of likes a particular review gets on the Yelp dataset. So what we try to venture out is whether can we predict whether a review is actually useful or no. What we did is, in the above same scenario, we swapped the rows and columns which were to review useful with the review stars. And what we came out to understand is that not all 5 stars are useful reviews, because those are not legitimate users yelping around, but the people who want this business to prevail. Moving ahead, now let's understand the second task that we've performed, which is logistical regression. To perform this with, we've used a text-based input and we've performed natural language processing on it using various methods in which we make a document term matrix. This matrix is nothing but a collection of words in an organized fashion in which we understand which words are more frequent in a particular scenario. In this case, we've used 100 rows, that is 100 reviews, and we have also attached our snippet out, which on the top right corner of the slide, which shows you which words are most frequently found in all the reviews. The stop words that you see on the second line from the top or the third line from the top is nothing but if at all you want to remove certain words like and, the, a, and I, as in you can see, which generate the most counts as 490s and 300s and 200s. If you think that is not useful for your classification algorithm or your regressional analysis, you can remove those words from using that stop words that is mentioned at the top. However, here we've not removed any words. We wanted to keep everything as simple as possible to understand how the relation of each and every little word a review has in itself can offer us with. And in the next photograph that you see below that is actually the curve, regressional curve of the number of words that a particular starred review has to itself. As in, if a review of 5-star has a lot of ands and those associated with it, to a review which is actually star 2 with the same number of ands and those. So the mean square error that we remove out with the logarithmic curve is plotted here for you to see. And we can see that there is a lot of issue, as in the least minima is not on the right side of the axis. It should have been a rather straight line. If it would have been a straight line, it would have been a better analysis, saying that if there is a review with 5 or 10 number of those giving a 5-star, the next 5 or 10 number of those will also give you a 5-star, which is not the case over here. Moving ahead, in the third slide, we've done decision trees. As always, we've used entropy, which is a guaranteed parameter provided with which we can understand whether a particular row element that comes in new can be classified as a business star. So here what we've done is we've classified the business star, the overall star for a particular business, and we've actually had 8 attributes, but when we perform the decision tree, we come out to understand that there are only 3 potential parameters that actually drive this rating, and which is nothing but parking space. And it's quite obvious, because if there's a fast food outlet or a cafe coffee day thing, it's always going to give you a price range which is very cheaper than a fine dine like Olive Garden. So it's pretty easy to understand that we can say that it's typically based on whether this place or a restaurant can afford to have its own valet parking or a space of its own to allow its users to park their vehicles and come and spend a gala time inside, or easy enough half an hour to 1 hour on their own dinner services. So this was something that we understood with this decision tree. Moving ahead, Rishabh will help you with the data model comparisons, the word clouds, and the visualizations that we've provided for this repository. Thank you.
Hi, this is Rishabh Lalwani. I'll be talking about data visualization done on our Yelp dataset. As you can see, we have built two word clouds for restaurant ratings. One is below 2.5 stars and one is above 4.5 stars. In a word cloud, basically, the word which is repeated the most is the most bold word in the cloud. As you can see in the first rating, where it's below 2.5, fast food and go back and will ever are the most common and repeated words. And the restaurant with ratings above 4.5 have food is great or I've got to go back is the most common and frequent words. We have also plotted a graph for this, a correlation plot. It's based on three attributes. One is the longitude, latitude, and review count. It plots the business stars from 1 to 5, 1 star being blue color and 5 star being ochre green color. Now Karan will be talking about the confusion matrix used in data visualization.
Hi, my name is
Thank
Karan Pankaj Makija, and I'm going to discuss the confusion matrix for KNN model that was built on the business stars. So, as you can see, we have plotted a line graph for multiple values of K's and calculated three most important metrics, that is accuracy, recall, and precision. Let's dig in into some definitions. Recall is, out of all the positive classes, how much are we predicting correctly? What about precision? Precision is, out of all the classes, how much have we predicted correctly? And accuracy, obviously, is all the true values in the dataset. The optimum K value is always the nearest to the square root of the number of training data. According to the graph, we predicted correctly that 100 neighbors would be a perfect choice because our length of the training data was 60,000. So the square root for 60,000 is obviously near to 200, and the nearest to 200 is 100. Coming to the conclusion, in the end, we like to thank our professor who has always been helpful throughout our project. There were lots of takeaways from this project which will help us as a team to grow and